Hello everyone and welcome back to IM Technos. In today's video, we will explore the anatomy of CloudFormation template, breaking it down step by step, starting with what a CloudFormation template is, discuss whether to use YAML or JSON, how to get started with templates, and dive into key sections of the template and a hands-on demo where we create, validate, and deploy a template. Finally, we will wrap up with some of the best practices. If you're already familiar with CloudFormation template, feel free to skip ahead to the hands-on section to save time. So let's get started. Here is a quick overview of what CloudFormation templates are. CloudFormation templates are declarative, meaning you describe what resources you need rather than how to create them. Think of it as a blueprint for infrastructure. Just like an architect uses blueprints to design buildings, a CloudFormation template lets you design your entire infrastructure in code, specifying everything from networking to compute resources. When it comes to resource definition, CloudFormation allows you to define all your AWS resources you need, like the EC2 instances, S3 buckets, and VPCs directly in the template. This makes it easier to manage and deploy all your resources as a unit without having to configure each one manually. And finally, CloudFormation templates support both YAML and JSON format. So YAML or JSON, which one should you use? Let's compare both formats. Here is a sample code for both JSON and YAML. JSON uses braces, square brackets, and double quotes to structure the data and define values. In contrast, YAML relies on indentations like spaces for its structure. No braces or quotes are needed unless absolutely necessary. JSON code can be a bit harder to read due to its strict formatting and heavy use of punctuations. YAML, on the other hand, is more human readable, especially for large templates. JSON files tend to be larger due to need for braces, quotes, and commas. YAML is more compact as it avoids unnecessary symbols. One key difference is that JSON doesn't support comments, which can be limiting for documentation within the code. YAML, however, allows comments using the as symbol. JSON is widely supported across various tools and programming libraries, while YAML become more widely supported, still sometimes requires specific tools or plugins in certain environments. In JSON, errors are easy to spot due to its strict syntax rules. YAML can be trickier because some errors like incorrect indentation can lead to harder to debug issues. JSON is a great for machine-to-machine interaction or when integrating with tools, where YAML is ideal for humans writing and reading templates, especially when working in teams. So which one you choose? It depends on your team and use case. If you are new to CloudFormation or want readability, go for YAML. If you are working with tools or systems that prefer JSON, stick with JSON. Personally, I find YAML more readable and simpler to work with, especially for beginners and larger templates. But at the end of the day, both get the job done. Now let's go through the steps to create a CloudFormation templates. First, identify the AWS resources you want to include in your stack. This could include the EC2 instances, VPCs, security groups, and more, depending on your requirements. Next, write the CloudFormation template in either JSON or YAML format. Once completed, save the file with an appropriate extension such as .json, .yaml, or .txt. After writing the template, it's important to validate it to ensure there are no errors. Finally, once your template is validated, use it to create a stack. To get started with the lab, ensure you have an active AWS account and S3 to manage buckets and objects, CloudFormation to create, modify, and delete stacks across different regions, and Cloud Shell to access and use effectively. Template anatomy or template structure. Now that we understand what a CloudFormation template is, let's break it down into its key sections. We have 10 sections in total, each designed to hold a specific type of information. Some sections need to be declared in a specific order, while for others, the order is flexible. However, when building your template, following the logical order shown in the slide can be helpful as values in one section might reference values from a previous section. And the resource section is the only mandatory section in a CloudFormation template, while all other sections are optional. Now let's start with AWS template format version. This section specifies the version of the CloudFormation template format. It helps ensure that the template follows the correct syntax and structure. And this is the latest template format version and currently the only valid value. If you don't specify this section, CloudFormation assumes the latest template format version. By the way, I'm using Visual Studio Code to edit the CloudFormation template, but you can use other tools such as Notepad or Notepad++ if Visual Studio Code isn't comfortable for you. Next, we have the description. It is useful for providing a human-readable explanation of what the template does. You can include details on the purpose of the stack or any specific instructions for the users who might use the template. For example, you can use provision and EC2 instance as a description. Now let's talk about the only mandatory section in the template, which is resources. This section defines the AWS resources that CloudFormation will create and manage in your stack, such as EC2 instances, VPCs, or security group. Without this section, there will be no resources to provision. In this case, we are defining an EC2 instance. My EC2 instance is the logical name of the EC2 instance within the CloudFormation template. You can refer to this name later in the template if needed. The type specifies what kind of AWS resource you are creating. In this case, we are creating EC2 instance. So we specify AWS EC2 instance. The property section defines the configuration options for the EC2 instance. In this example, the key properties include the instance type, image ID, key pair or key name, security groups, and tags. The values for the image ID, key pair, and security groups are specific to North Virginia region as I plan to deploy this stack in that region. Now we are ready to provision an EC2 instance. Let's pause here to create the stack. Afterwards, we'll come back to explore other sections of the template. Here is what we will do. The template is created. We'll upload into S3 by creating a bucket. We'll validate it and then create a stack to provision EC2 instance. Step 1 is already done. We'll create a bucket and upload this template. We'll validate the template and then we'll create the stack. Log into AWS Management Console. We will do our hands-on North Virginia region. Now create a bucket and upload the CloudFormation template. In the Management Console, type S3 in the search bar and select the S3 service. Click on Create Bucket button. Choose a unique name for your bucket, such as IamTechnos, CFN template, and select the desired AWS region. Leave all other settings as default and click Create Bucket. Navigate to the bucket you have just created. Click on Upload button and either add the CloudFormation template file from your local machine or drag and drop. Once the file is uploaded, click Upload and then close. Click on the uploaded file and copy its object URL. Let's validate this template. One way to validate is by using the Cloud Shell. In the AWS Management Console, you will find Cloud Shell in the top right corner. It is an inbuilt CLI environment where you don't need to configure access keys. You can directly run CLI commands within the region where Cloud Shell is initiated. So maximize the screen. So you can run AWS CloudFormation, validate, template, template URL, and paste the object URL here. And enter. If you don't see any error message in the output, you can confirm that your template is error-free. Since there are no error messages, our template is now ready to be used to create a stack. Navigate to the CloudFormation service in the AWS Management Console and select the service. Click Create Stack and choose with new resources. Choose an existing template. Under Specify Template, choose the S3 URL and paste the URL of the template you copied earlier. next to continue. On the next screen, enter a name for your stack such as EC2Stack and configure any necessary parameters. Since our template doesn't mention any parameters, you can skip this step. Click next. You will then given the option to configure additional settings like tags and permissions. For now, we can skip these and proceed, but feel free to adjust them as per your requirements. Finally, you can reach the review screen, which provides a summary of the stack and the resources that will be created. Double check everything and click submit to create the stack. CloudFormation, start processing your template. You can monitor the progress of your stack creation in the Events Updated tab. Once all the resources are successfully created, the stack status changes to Create Complete. This indicates the stack was successfully created. If there are any issues during the resource creation, for example, missing permissions or invalid configuration, the same stack status changes to rollback in progress, and CloudFormation will attempt to undo the changes it made to prevent partial or incorrect resource provisioning. The Resources tab in the CloudFormation stack offers the detailed information about all the resources created or managed by the stack. In this case, the EC2 instance. At this stage, your stack has been successfully deployed and the EC2 instance is ready to use now. Let's revisit the template. Imagine you want to deploy EC2 instances in multiple regions. Each region has its own specific AMI ID, a security group, a key pair. Instead of manually updating your template for each region, we can use mapping section. We can use this section to handle the configuration based on the region automatically. This makes the template dynamic and adaptable to different regions, and you don't have to maintain multiple versions of the same template. Now let's see how we can use the mapping section in action. The mapping section is placed above the resource section in the CloudFormation template. A region map is the name of the mapping defined within the mapping section. For example, if you deploy the stack in North Virginia region, US East 1, the template will automatically use the AMI ID, security group, and key pair values defined for that region. Similarly, if the stack is deployed in California region, which is US West 1, it will use the corresponding configuration for that region. In the resource section, instead of hard coding the AMI ID, security group, and key pair, we will reference the region-specific values using the findInMap function. FindInMap looks up a specific value from the region map mapping section based on the region. Similarly, the key pair and the security group. And you can add a comment referencing the mapping section for region-specific values. And a new tag as my new EC2 instance. Let's run this template again, this time with the mapping section included. I have uploaded the updated template in the S3 bucket and copied the object URL. To validate the updated template, run the following command. So clear the screen and then run the command again. Validation is a crucial step that should be performed every time before using the template in a stack to ensure it's error-free. So the output confirms that there are no errors. First, I'll create a stack in North Virginia region. Since there is already a stack we created earlier, I will delete the stack and create a new one using the updated template. So click Create Stack and choose with new resources. Choose an existing template. Under Specify Template, choose the Amazon S3 URL and paste the URL of the template you copied earlier. Click Next to continue. On the next screen, I'll name it as US East 1 stack. Click Next. Proceed with the default settings for tags and advanced options. Click Next and then Submit. Wait for the instance to be created successfully. I've waited long enough. Now it's time to refresh the Events tab. Once it shows Create Complete, we can head over to the Resources tab. From there, we can access the EC2 instance which has been provisioned successfully in the North Virginia region. Next, I'll create another stack in California region following the same process. So go back to the CloudFormation service. Click on California region. Click Create Stack and choose with new resources. Choose an existing template, under specify template, copy the Amazon S3 URL. And next to continue. This time, I'll name it as US West 1 stack. Click Next. Proceed with the default settings. Click Next and then Submit. Click Refresh and go to Resource tab. And you can see the instance is provisioned in California region as well. Okay, so this is a California region and you can see the instance. So using the same template, we can seamlessly create resources in different regions. Now let's go back to the template. If you notice, in the resource section, we have hard-coded the instance type as T2 micro. But what if we want to create instances with different types based on specific requirements and also without having to update the template every time? This is where the parameter section comes into play. Instead of hard-coding values, we can define placeholders for the user input. So in this template, the parameter should be on top of the mapping section. And we have a parameter named as InstanceType. This parameter allows the user to specify the type of EC2 instance they want to create. The type specifies the data type, in this case, a string. Description provides a brief explanation of what that parameter does, so users know its purpose. If a user doesn't specify a value, the template will use the default, which here is T2 micro. Allowed values restrict the input to specific valid options, in this case T2 micro or T2 small. This ensures the user doesn't enter an invalid instance type. If a user enters an invalid value, this is the error message they will see. And in the resource section, need to update the instance type property by referring the instance type parameter using the ref function. So we are actually referring this particular parameter. Save the template. Let's run this template with the parameter section. Remember to upload the updated template in S3 every time you make changes to ensure the latest version is used. Copy the object URL. Validate the template. So clear the screen. Run the command again. It shows no errors. Next, navigate to the CloudFormation service. We have stacks created in both North Virginia region and California region. You can choose any stack in this case. I'll select the stack in North Virginia region. Select the stack. Click on Update. Select Replace Existing Template. And place the S3 URL of the latest version of the template. And click Next. In the parameter section, you will now see an option to select a value for the instance type. The existing EC2 instance was created with T2 micro. So this time, I'll select T2 small and submit the stack. Click Next and then Submit. Now let's head over to the EC2 dashboard and keep refreshing to observe the changes. Since there is already an EC2 instance running, CloudFormation will stop the instance, update the instance type to T2 small, and then restart it. If we keep refreshing the dashboard, we will see the instance running with T2 small as the updated instance type. So what we have done, we already have a stack in North Virginia region, which has the EC2 instance of T2 micro as an instance type. Now we updated the stack with a new template so that the CloudFormation updated with a new instance type. Now when you run the stack, the resources will be created. However, instead of navigating to each resource to get the details, you can simply get essential information like the instance ID and the public IP address directly from the Outputs tab. To make this possible, you need to include an output section in your template. So let's now move on to discuss the output section and explore how it works. The output section serves several purposes. It can be used for nested stacks, allowing you to pass information between stacks. It also supports resource sharing, helps with automation integration, and simplifies the process of retrieving critical data like resource IDs or endpoints. For now, let's add the output section to retrieve the instance ID and public IP address. This way, once the stack is created, we can quickly access the details from the output stack. Instance ID will return the instance ID of an EC2 instance using the ref function. The public IP address will retrieve the public IP address of the EC2 instance using getATT function. So let's save the file and run the template again. The updated template is uploaded, validated. Next, navigate to the CloudFormation service. Select the stack, click on update, select replace existing template, and paste the S3 URL of the latest version of the template. Click next. In the parameter section, I will select T2 micro. Please understand, T2 micro is under the free tier, whereas T2 small is not. So you may get charges if you are doing the hands-on with me. Click next, go with the default settings, next, and then submit. There is already an EC2 instance running with T2 small instance type. It will update to T2 micro. So let's wait for the CloudFormation to update the stack. When it updates, it not only does it changes the instance type to T2 micro, but it also displays the instance ID and the public IP address in the outputs tab. So go to resources, go to EC2 instance. So the instance is updated to T2 micro. Let's go back to the CloudFormation dashboard, navigate to the outputs tab to find the instance ID and the public IP address of the EC2 instance. So we have covered the essential sections of a CloudFormation template that are crucial to get started. There are additional sections which we won't dive much into it now, such as conditions, which allows you to specify when certain resources or parts of the template should be created or configured based on conditions you define. For example, you can create resources only in specific regions or environments. We have metadata. It provides additional information about the templates or its resources, often used to include comments or store information for automated process without affecting the stack itself. Since JSON doesn't support comments, the metadata section can be used to add comments if you are working with a template in JSON format. And we have rules. This section is used to define constraints on input values, such as parameters, by creating validation logic that ensures the provided values meet certain criteria. And lastly, transform, which is used for AWS specific macros like AWS include or AWS transform. So maybe we will explore them in future videos if hands-on is needed. Let's do the cleanup. First, delete the S3 bucket where the CloudFormation template is stored. Remember, you need to empty the bucket before deleting it. Now delete the bucket. Next, delete the CloudFormation stack in both North Virginia region and California region. So presently I'm in North Virginia region. Click on delete. Go to California region. So click on delete here as well. So the stacks will terminate the instances as well. That concludes our hands-on session for today. But before we wrap up, here are some tips to keep in mind when working with CloudFormation templates. Always validate your templates before deploying them to avoid errors. Use parameters and outputs to make your templates reusable and shareable. Follow the principle of least privilege when defining IAM roles or policies. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.